This is Logan Hall with the Eastern Shore Regional GIS Cooperative. You're watching a video tutorial on how to reclassify raster datasets in ArcGIS for desktop. In this tutorial, we will use a hypothetical scenario for an agricultural site analysis for a vineyard in Garrett County, Maryland. Our parameters are south-facing between 160 and 200 degrees azimuth with a moderate grade slope of 8 to 12% rise. Using two methods, our first in Spatial Analyst Toolbox, we'll reclassify slope, reclassify aspect, and merge the two classifications. Our second method, using the image analysis window, we'll generate slope and aspect, reclassify slope and aspect, and merge the two classifications. Our first method uses geoprocessing tools in the Spatial Analyst Toolbox. You will need an active Spatial Analyst extension to perform the following tasks. If you do not have Spatial Analyst, you may wish to proceed further in the video for our second method using the image analysis window. So to start, we'll open our Customize dropdown, Extensions, and ensure that Spatial Analyst has been turned on. Our scenario is working in Garrett County, and since we need to use the functions, we need our DEM_M image service. First, we need to apply our slope function. And apply our symbology appropriately. We are working in the northwest portion of the county, so we'll zoom into our area of interest and draw our polygon for extraction. In our previous videos, we have covered accessing the Maryland LiDAR image services, accessing image service functions, as well as extracting from image services for local processing. Click Yes to add data to the map, and we can temporarily turn off our image service. If you double-click our graphic, we can change our fill to no color, as we will be using the same graphic in the next step of our video tutorial. So from here, we can either use the search tab if you have it open, or the search icon at the top. Type in Reclassify, which is found in the Spatial Analyst Toolbox. Our input raster will be GAR_slope, or the recently exported raster dataset. Reclass field is value, and we want to delete all entries, so highlight, delete. Our first added entry will be 8 space 12 with a new value of 1. If we click Add Entry again, it'll automatically drop in an entry for no data. And we can remove the blank entry at the bottom of our table. Select your Output Workspace folder. and name our output raster. Remember, this output will be in an Esri grid format, so the naming convention must be within our 13-character limitation. Check the box to change missing values to no data, and click OK. As we zoom into the resulting dataset, we can see that values of 1 are within our slope percent rise of 8 and 12. Also notice how setting the cell values outside of our range to no data removes them from the dataset altogether. Now that we have reclassified our slope dataset, we need to do the same going back to our image service for aspect. We're going to jump back to full extent, turn on our image service, and turn off our slope reclassified, as well as our exported slope raster. Zoom back into our selected graphic. If for some reason this was deleted in the previous process, use the draw tool. You can turn on one of these layers as reference and create a new selected graphic polygon. We need to open up layer properties for our image service, processing templates, and select aspect. Click apply and click OK. Once again, we're going to export data based on our selected graphic. Navigate to your output workspace folder, select format, and rename your raster dataset appropriately. Add the new layer to the map and turn off our image service. Once again, in the search bar, we need our Reclassify Spatial Analyst geoprocessing tool. This time our input raster will be GAR_aspect. Again, reclass field is value, and we want to delete all entries. We're going to add entries for our old values, 160 space hyphen space 200, and our new values will be 10. We're going to add one more entry to generate our no data and remove our bottom row. Again, navigate to your output workspace folder, and name our output raster. Check the box to change missing values to no data, and click OK to run. Again, as we zoom into the resulting dataset, cells with a value of 10 are within our azimuth range of 160 to 200 degrees, which is south-facing slopes. If we turn off the underlying raster, we'll see value ranges that did not meet our parameter have been dropped from the dataset. The final step will be to merge the two classifications for further analysis. Now that we have our slope and aspect datasets reclassified, we can merge these together to help identify regions of moderate grade, 8 to 12% slope, as well as south-facing, 160 to 200 degrees azimuth. We can bring our two reclassifications back into the map. If we zoom in, turning the layers on and off, we can see the regions that we're looking for, the areas where both cells overlap. To do this with Spatial Analyst, we'll search for the Raster Calculator geoprocessing tool. Using the icons and variables within the window, we'll double-click slope_RECL, use the addition icon, then double-click our aspect. Name our output raster, and click OK to run. Our analysis of this scenario is now complete, with all three datasets identifying moderately graded slopes, south-facing slopes, and our last output raster where both parameters are met. Our second method uses the image analysis window, which is available in ArcGIS for desktop versions 10.2 and later. The image analysis window allows for quick, efficient processing through the use of raster functions. This results in temporary outputs added directly to the table of contents in your map. Note, if you close ArcMap without saving, you will lose these raster layers. The user can select which layers to export as new raster datasets or layer files, again improving their workflow and time management when processing raster data. Once again, we'll start using Garrett County DEM in meters. Then we need to draw a polygon graphic to use as our selected feature for exporting. Northwest portion of the county. Navigate to your output workspace folder. Name your raster and click Save. For more information on connecting to the LiDAR image services or extracting from the image service for local processing, please refer to the appropriate documentation. Click Yes to add the data to the map, and we can turn off our image service and remove our selected graphic. If we go to the top, click Windows, we can open our image analysis window. You can grab and select the window and pin it to the side if you'd like. The image analysis window is split up into 4 different sections: the layer list or pane, display, processing, and mensuration. Everything starts from the layer list, and it coincides with layers in your table of contents. Single click to select your layer, which activates the 3 panes below. Under processing, if we select the Add Function button, we can start chaining together our raster function template. The function template editor allows us to create raster functions for on-the-fly processing in ArcMap. The outputs from the function template are temporary. However, they can be exported as raster datasets. The top line, with extension .afr, is the function chain itself. In ArcGIS for desktop 10.3.1 or later, these functions can be saved as XML files and shared for use, or applied to image services themselves while publishing to ArcGIS for server. To add our first function, slope, we need to right-click the identity function, insert, and scroll to the bottom to select slope. We need our output measurement to be %rise, and click OK. Notice how the slope function has replaced the identity function. So our function chain reads, our Garrett exported raster dataset with a slope function applied. Click OK to output our temporary layer. Notice the new layer is added to the table of contents, named FUNC_GAR_EXP. This layer is temporary. If we were to close our MXD without saving, this layer would be lost. We can right-click on Data Export, or using the image analysis window, select the raster dataset and click Export. Select our output format as regrid. Make sure you are within your output workspace folder, and name the raster appropriately. Now we have GAR_slope added to our layers in table of contents. So we can remove our temporary function layer. Repeating the steps for aspect, we can turn off our Garrett slope, single click our GAR_EXP, which is our local copy of our raster dataset for processing. Again, click Add Function, right-click the identity function, insert, and add our aspect function. Default parameters, click OK. Again, make sure that your raster dataset is underneath your aspect function, and click OK. We need to select our function temporary layer and export. Select our output format, select our output workspace folder, and name the raster appropriately. Ensuring that we have our local aspect dataset for processing, we can remove our temporary layer. Now that we have our slope and aspect derivative datasets, we can continue processing for further analysis. We'll start with slope. So highlight your slope dataset in your image analysis window and select Add Function under Processing. Right-click the identity function and insert Remap function. We'll set 8 for minimum, 12 for max, with an output of 1. Make sure to check the box to change missing values to no data, and click OK. We turn off our slope dataset. We can see the return values of our function have a cell value of 1, representing moderately graded slopes between 8 and 12% rise. we single click our function temporary layer in our image analysis window, we can export it for a local copy. Again, select your output workspace folder and rename our raster appropriately. We can delete our temporary layer, turn off our slope classification, and continue with our aspect. So turn on the aspect layer. Once again, add function, and insert our remap function. For aspect, our minimum is 160, our maximum is 200, with an output of 10. Again, check the box to change missing values to no data, and click OK. Single click our function temporary layer in the image analysis window and export for local copy. Select your output workspace folder and rename our raster appropriately. We can delete our temporary layer, and we can remove our derivative products, our export, and our image service, leaving us with our slope and our aspect reclassifications. Our last step is to merge the two classifications for the final analysis. Doing so in the image analysis window requires another function. This can be performed on either of the two datasets. We'll use our slope reclassification, add a function, right-click identity and insert arithmetic function. Our first input raster is our slope reclassified. We'll need to input our second raster by navigating to our output workspace folder and select our aspect reclassification for the second input raster. Going to make sure our operation is plus and click OK to add it to the function chain. Within our function template editor, notice our arithmetic function contains both datasets. Click OK to run the temporary layer. Selecting our current function output, we can export this for local copy. Connect to your output workspace folder and rename the raster appropriately. We can remove the function layer and we're left with south-facing slopes containing a cell value of 11. These identify slopes between 8 and 12% rise, between 160 and 200 degrees azimuth. For additional resources, please visit imap.maryland.gov, and to access your Maryland LiDAR topography server, visit lidar.geodata.md.gov/IMAP.